Question number 38. In an alpha decay, an alpha particle is emitted even though its kinetic energy is smaller than the height of the nuclear potential barrier. Okay. Then, so nuclear potential barrier. This is your nuclear potential barrier. Okay. And then suddenly you observe. Okay. Wrong. Right. Okay. So then alpha particle is being emitted from the barrier over here. What makes the alpha decay possible? So where is the alpha decay getting emitted? Alpha decay is getting emitted from a radioactive nuclei. It is not available outside, right? Okay. So therefore, conservation of energy does not apply. No. So why does it emit? Why? Though, okay. So it's very clearly given the question. Alpha particle is emitted even if the kinetic energy is less than the height. What kind of phenomena is this? It's nothing but your quantum tunneling over here. Tunneling over here. So now let us look for the tunneling over here. So the de Broglie wavelength of the alpha particle is larger than the nuclear radius. No. Binding energy of the alpha particles is greater than the binding energy. No. The alpha particle wave functions extends outside the nucleus. Usually whenever we have a tunneling phenomena, the wave functions of such phenomena will now be it will be extending like this. So it will not exactly go to 0, it will be like this over here. What does this actually indicate? It tells you the probability of locating the particle outside the nucleus is also finite. Okay, that's what it tells you. You would have learned this in electron in the box. The same thing is applicable over here, and hence you see the answer D is the correct answer.